Okay, good evening, everyone, and thank you for joining us in this Global Entrepreneurship Week Bahrain event titled Astropreneurship, Opportunities in the Space Industry. This event is part of a series of events taking place during the week, and it's addressing various topics around entrepreneurship. Bahrain celebrates GEW annually, joining over 150 countries around the world, making it possible for anyone, anywhere around the world to start and scale a business. My name is Assam Hamad, representing Tamkeen, the Bahrain Labor Fund, and Gen Bahrain, the Global Entrepreneurship Network chapter of the Kingdom of Bahrain. This session is intended to highlight opportunities in the new space industry and shed some light on the broad applications within this disruptive sector. The space sector is part of people's daily lives, and we're becoming dependent on the services that are becoming possible by advances in the space industry. Space investment brought us GPS, and without GPS, we can't have Uber. Without GPS, we can't have Google Maps, and projects such as SpaceX, Starlink, for example, which is working to create a global satellite internet with more than 42,000 orbiting satellites, will provide rural and underdeveloped areas around the world with high-speed internet. Similarly, we have projects like Space Mobile, which is creating very powerful networks that provide mobile connectivity, 4G, 5G, everywhere on the planet. The revenue generated globally by the space industry may increase to more than 1 trillion by the year 2040. And this year alone, investment in the startups in the space industry topped the 12 billion, according to Space Capital. In Bahrain, Amazon Web Services have recently announced their opening of the ground station. The ground station is a fully managed service that lets companies control satellite communications, process satellite data, and scale satellite operations. And we'll be speaking more about that today. Of course, this comes after Amazon Web Services announced its data centers launched in Bahrain last year, and Bahrain is now officially a AWS region. So all of these advances in the local infrastructure, coupled with the Bahrain National Space and Sciences Agency's mission to devise a comprehensive program to embrace and develop activities related to the space sector, research and studies, makes space tech or new space a very lucrative and high potential sector. So today we are very happy to welcome Dr. Bidushi Bhattacharya, co-founder and CEO of AstroHub, to conduct this workshop on astropreneurship. Dr. Bhattacharya is an ex-NASA scientist, and she has close to 3 decades of experience in this field. She will be joined by Mr. Guido Baraglia, who is a Principal Business Development Manager at Amazon Web Services Ground Stations, who is currently based in Italy and will tell us more about the ground station and how we can seize opportunities by their presence in Bahrain. Also, we are joined by Rasha Al-Ahmed, who is the Chief of Strategic Planning at the Bahrain National Space and Sciences Agency. We'll kick off the session with Rasha, who will tell us about the national plans for the space sector and objectives of the NSSA. So with that, I hand over to you, Rasha. If you can please shed some light on our national plans and objectives of the NSSA.
Thank you, Assam. Allow me, please, to show my presentation. Okay, so good evening, everyone, and thank you for joining this session. My name is Rasha Al-Ahmed, and I'm the Chief Strategic Planning Officer at NSSA. I am very pleased to be here today, part of the Global Entrepreneurship Week, to promote entrepreneurship in the field of space, a very prominent and a green field. Allow me in the following slides to introduce the Kingdom's national space policy that promote entrepreneurship and investments in this field, and introduce the NSSA strategic plan. His Majesty's inspiring vision in the field of space for the Kingdom of Bahrain is placing the kingdom amongst developed countries in the fields of space, its sciences, and its various applications, with the aim of achieving comprehensive and sustainable development for the kingdom. The National Space Policy have been formed to fulfill His Majesty's vision and developed in accordance with international best practices, considering Bahrain Economic Vision 2030 and addressing the United Nations Sustainable Development Goals, noting that all 17 SDGs are positively impacted by the benefits of space, and almost 40% of targets benefit from space and its sciences and applications. The National Space Policy was developed to be the main reference point to all national strategies related to the space sector, to translate His Majesty's vision into achievable and national objectives, to define NSSA's approach and roles of stakeholders, clarifying through its requirements success factors, and finally, regulating efficiency and quality standards in its governance. The National Space Policy consists of three main sections: objectives that are more of aspirations related to the space sector, requirements that are success factors, governance that includes the evaluation process while implementing those objectives. The policy includes 5 objectives. In the following slides, I will be explaining each objective individually. The first objective is to benefit from space, its sciences, and applications to support comprehensive and sustainable development for the Kingdom of Bahrain. This will be achieved through national capacity building and development, implementing awareness programs, the use of Earth observation data to enhance government services, including supporting planning and decision-making. The second objective is to achieve presence for the kingdom in space. And this will be achieved again through capacity building, encouraging scientific research in collaboration with public and private sectors, ensure actual presence in space through building and launching satellites, training and sending of astronauts on scientific space missions, and taking part in international projects to make peaceful use of space that serve humanity, enrich knowledge, and encourage creativity. The third objective is to attain leadership for the kingdom in the field of space. And this will be achieved through collaborating with various partners to achieve similar initiatives, establishing a well-developed infrastructure, again, national capacity building and development, boosting scientific research through collaboration with research centers and higher education institutes, and endeavoring to make the kingdom a regional and international center for holding various space-related commercial and scientific events. The fourth objective is to contribute to the stability and safety of the space environment and sustainability. This will be achieved through transparency and exchange of knowledge to unrelated space activities with relevant authorities and bodies, the rational use of radio frequencies, spectrum, and orbits, implementing proper safety, security, and related infrastructure that support it, and taking part in international initiatives and efforts to minimize space debris where possible and take other measures related to safety. Finally, which is very important, is to create a new space sector locally that contribute to national economic diversification. And this will be achieved through developing legislations and regulations that regulate space activities and attract investments in the space sector, and that would ensure rights for both end users and investors, and paves the way for entrepreneurs and SMEs. Secondly, it is again through building national capacity and implementing awareness programs, encouraging investments in space-related industries, and supporting export of national products by providing facilities, incentives, and protecting creativity. The second part of the policy is requirements, and those are basic success factors that are required to accomplish the objectives of this policy. The Kingdom has 7 requirements. First is to spread awareness about space science, technology, and applications, considering different segments of the society. Identify national needs of space information and Earth observation data through listing and regularly updating those needs. Building capacity. Create the appropriate regulatory environment. Rational use of frequency spectrum and orbits through national and international collaboration and coordination to ensure optimal use for both. Partnerships. Building strategic partnerships to support efforts in the space sector. And finally, providing finance by collaborating with government and private sectors to finance national initiatives and space projects. The third part of the policy is about governance, which is again evaluating the process while implementing those objectives. For success in establishing the space sector, it will depend on determining stakeholders that should work collaboratively in an integrated manner to implement the space policy, regular review and evaluation for improvement opportunities, measuring quality performance, measuring progress made in the implementation of initiatives and projects emerging from this policy. Moving on to the NSSA strategic plan that was developed in accordance with the government action plan. Dr. Engineer Mohammed Al-Asiri's inspiring mission for the NSSA is to apply integrated initiatives and programs to respond to national requirements and to sponsor and develop space scientific technological activities, research and concepts for achieving comprehensive and sustainable development. The NSSA has 6 strategic goals. In the following slides, I will be explaining each goal and give a high-level progress against each. The first goal is to promote space science, technology, and applications by spreading awareness about space application benefits, introducing latest trends and technologies, discoveries in this field, and finally encouraging individuals to contribute towards the space field nationally and internationally. In terms of progress, we have conducted many local events targeting different audience groups, considering different segments of the society. The second strategic goal is building capacity in the fields of satellite manufacturing, satellite operations, data and image processing and analysis. This would happen whether through academic and applied programs, or attending specialized trainings, and even work on joint projects that achieve knowledge transfer. This will pave the way for building a knowledge-based society and converting to entrepreneurship in this vital sector. In terms of progress, in our current strategic plan, we have focused on building capacity of our staff to establish a well-qualified team that can help achieve NSSA goals. We have also conducted several workshops for stakeholders to build national capacity. The third goal is constructing a sound infrastructure for achieving comprehensive and sustainable development and for ensuring a leading position. This includes creating appropriate regulatory environment governed by laws that regulate space-related activities in this field. We, NSSA, with relevant stakeholders, have completed drafting the National Space Policy, revising it by a specialized house of expertise before obtaining the required approvals and announcing it. We are still in progress to develop the required framework with relevant stakeholders. The fourth strategic goal is establishing regional and international relationships of cooperation to support national efforts in the space sector. The Kingdom have already partnered with many space organizations and research centers, some of which are listed below. The fifth is responding to national requirements by providing space information and Earth observation data to different stakeholders, and this is to support comprehensive and sustainable development. In terms of progress, we have completed government needs analysis and are continuously refining those needs. We have started offering services. Further information about their services are found on our website. And we are in progress to initiate a project for that purpose. The sixth and final strategic goal is encouraging the Kingdom to become a party in international conventions and agreements that govern activities in the exploration and use of outer space. The Kingdom is a member of the United Nations Office for Outer Space Affairs. We are also a member of COPUS, which is the Committee on the Peaceful Use of Outer Space. We have signed 2 out of 5 main international space treaties developed under the UN, while the 3rd is in progress. NSSA is continuously representing the Kingdom in space conferences for potential collaboration and partnerships. To fulfill our strategic goals, NSSA is currently working on the following 4 initiatives as part of our current strategic cycle. The first initiative is to establish a data analysis center for processing and analyzing satellite imagery and data. The second initiative is to launch nano satellites for the purpose of capacity building. The third is launching remote sensing satellites to fulfill national needs of space information and Earth observation data, and finally establishing a ground station. To conclude, at NSSA, we believe in strong partnerships to support our national efforts in the space sector. Partnership frameworks could include supporting awareness programs, implementing joint initiatives and projects, and supporting research. You may approach the NSSA for potential collaborations through our website by filling the partnership form. For further information, please visit our website, subscribe to our quarter newsletter, follow us on Twitter, YouTube, or Instagram, and if you have more questions, please use the contact form on our website. Thank you for allowing me the opportunity to present the National Space Policy and the NSSA Strategic Plan, both playing a vital role in promoting entrepreneurship in the space sector. I will leave the floor to Mr. Guido, Baralia to introduce himself. Isam. Thank you.
Thank you so much, Rasha, for that very useful information. I think we can confidently say that the NSSA's mission and objectives very much aligned to, several strategic projects across various bodies within the kingdom. And we have definitely built the right associations and participation with international bodies to enable us to actually become a global player in this field. And as you stated, Bahrain's diversification strategy started many decades ago, and the space sector now is one of those sort of untapped sectors that can really help us to further diversify our economy going forward. You've already listed various areas where the private sector may actually contribute through their own ventures. I believe there are very specific applications that the market can already tap into today. So it's very exciting to see all this work. Thank you so much, Rasha. We appreciate that. And, as part of our work in developing the right infrastructure for Bahrain to attract, the right investments, the right initiatives, over the last few years, we've been working very closely with Amazon Web Services to name Bahrain as their Middle Eastern region. And in 2019, this was finally announced, and the data centers are ready to be used for various applications. And since then, AWS has launched its satellite ground station in Bahrain. And the ground station will bring opportunities for entrepreneurs and innovative startups to experiment and fail fast, as they say, as they develop new products and services. Customers would be easily able to integrate satellite data with other AWS services, either in the same region or with other AWS regions internationally, as the high capacity backbone is available. So it gives me a great pleasure to welcome Guido Baraglia, who can tell us more about this ground station and what it could really mean for Bahrain and even for the private sector in Bahrain. So I hand it over to you, Guido.
Thank you very much, Isam, and thank you for the organizer and the fellow panelists for this opportunity. Let me start with a bit of history. Recent history. You rightly say that AWS has opened a region in Bahrain, and that's a major point in our development in the region. But as well, we have installed the first ground station service outside of the United States in Bahrain. So the two antennas that are made available after the start of operations in May 2019 were actually the first non-American elements of the ground station service. Those antennas, two antennas, can actually achieve very high throughput in receiving data from Earth observation satellite. And as you mentioned at the beginning, this is a fully managed service. So the operator of the satellites or user of the satellite only need to concentrate on the core business, which is actually the technology behind collecting information through images, through radar, through hyperspectral sensors, whatever is actually fit for the purpose of sustaining the specific business segment. I want to again go back and connect to what you said at the beginning about the way satellites are embedded in our own life, and that made me laugh, your introduction, because it's actually the same type of narrative I use every time I have to do that. My example is pretty simple. You wake up in the morning, you switch on the radio, the TV, or internet, and you read about news from around the world. Chances are a number of those informations are actually coming through the satellite. And then you look at the weather forecast to get dressed, to understand how you have to dress. And that happened a lot. I can tell you, I'm Italian, so that's something that I do quite often. And then you get out and you mention that the GPS, jump on your car, and then you set a destination on a satellite navigator. And then again, it's another of the many, many elements that are related to satellites in our lives. Supply chains, navigation, both in the air and on the sea, information, databases, education, healthcare, virtually everything, especially in this specific period of our existence, goes through satellite. So Amazon decided in November 2018 to start a new service called Ground Station, to provide the ability to satellite operator to actually downlink information from their own spacecraft without having to build their own ground infrastructure. And we know that the ground infrastructure in a satellite operation, especially related to Earth observation, is extremely expensive. It's very CapEx intensive. And so when you are a startup that is actually at the same time building a satellite, building the business case, making agreement to launch the satellite, to sell the information that you can collect, adding the layer of ground infrastructure into discussion is quite an heavy burden. So the ability to use a ground station as a service and just operate the ground station on a per minute base, and this is what our customers do with AWS Ground Station. They can reserve the access to a specific antenna over a limited period of time, normally for low Earth observation, low Earth orbit satellite. In the remote sensing, we're talking about 6 to 8 to 10 minutes, depending on the type of satellite, and then download those data through their specific antennas. Again, in Bahrain, we have 2 antennas, but we have 2 antennas in other 6 locations around the world, 2 in the United States, 2 in Europe, 1 in South Africa, and 1 in Australia. This global network of antennas actually allow the satellite operator to minimize the latency in terms of retrieving the images collected by the spacecraft, processing those images, and then making those images available to the market. We need to remember that a startup that enters the remote sensing and Earth observation business has one objective alone, which is to sell intelligence in terms of data to users around the world. And that's what Ground Station allows to do that in the shortest delay possible. The other advantage is that those ground stations are actually connected to the AWS network infrastructure. So the data can be transported from remote stations into whatever virtual private network the operation is actually using. And that is included in the service. We know that transporting data around the world could be, again, a heavy burden, and Amazon Web Services actually support that from the acquisition of the data. Scalability, again, is a big factor in here, and this has been mentioned before. You don't need to think about a worldwide network. It exists already, a worldwide network of ground station. You just need to decide which ground station is actually the most fit for the specific operation. And for that, I don't want to get too much into technical, but we have APIs. So we have an interface that could be managed by the satellite operator to actually automate all these operations. It doesn't have to be a resource-intensive type of task. The mission control software can actually be used to define acquisition passes from specific satellites and then transfer the received data in real time to the destination region of the customer. Process. We need to remember that we can do all sorts of processing within the cloud, from simple data recognition, geotagging. We can do all sorts of value-added processing into the data, into the images that we are receiving. The process is pretty simple. customer generates a mission profile for a specific satellite or constellation of satellite. Each mission profile is stored into the cloud, into the virtual private network of the customer. This is used for scheduling. There is either a direct dashboard for one of missions, or you can use the API, as I was saying. The cloud is also used for command and control. So the satellite as a machine can also be controlled through the cloud. Different configuration, different settings, different orbital attitude, different tasking for taking pictures of images of specific part of the planet. Ground station receive data from anywhere, transfer those data into the cloud, and process and distribute those data through instances that are already present, that are already available within the AWS cloud. From a technical point of view, we have adopted an innovative approach. We use digitized signal from the antenna into the cloud. So even from a data protection point of view, this is actually achieved from the antenna pedestal into the destination of the operation. And applications are actually wide and variable. You have Earth observation that can be used for agricultural purposes. You can use that for fishing purposes, but as well for navigational purposes, for shipping lanes, for ports, for monitoring energy installation, oil and gas, rather than wind farms or other sustainable installation. And this is actually the big difference as far as the satellite market is concerned. The operators can actually move all the workload into the cloud and just concentrate on the core business, which is the sensor on the satellite, which is the data that the sensor is going to collect from space, which is the output of those data, how to provide value to the different actors that will actually use that spacecraft. There are different technologies. We have customers that use optical satellites, so take images with advanced cameras. Of course, quite intuitively, cameras will have limitation. They cannot work overnight. They cannot work when the weather is clouded or is overcast. We have satellites that work with a synthetic aperture radar, so they use a frequency like any other radar, and in this case, satellite can operate 24/7 and can operate in each and every weather condition. And we have multispectral satellite that can actually collect information that are quite useful. You can, for example, collect information on the humidity of the soil. And then if you do have agricultural farms, if you are growing crop, then you can decide how to optimize irrigation. You can collect information on the chemical of the soil, and then you can optimize eventual use of chemicals to implement the yield of your crops. You can use hyperspectral images to actually assess the growth of the crops. And like that, you can actually apply to virtually any possible industry. You can have satellites in low Earth orbit that are collecting IoT devices information from, for example, refrigerated containers. You're shipping a batch of precious goods into a refrigerated container. You want to make sure that the frozen chain remain within the limit all the time, and then you can use an IoT device to collect temperature and humidity within the refrigerated container. But of course, if you are on a ship in the middle of the Atlantic Ocean, you have issues in connectivity. So you can use IoT devices and satellite that have IoT receivers that could actually collect those information and download those information into the main control center. But like that, you can think about satellite with infrared sensor that could detect leaks into dangerous gas. You can detect fires, forest fires, and so like raise alarm faster than it could be with terrestrial monitor. And like this, you can think about whatever you can think about. You can actually apply and have a solution for the satellite. The idea, and I conclude, the idea of AWS is actually providing this service has a more accessible way. And it's actually, I was reading before, is actually the description of this very workshop. It is access entry into the space industry is not as challenging as before. And I think AWS Ground Station is doing exactly that, removing the barrier, lowering those barriers, allowing more and more startups and companies and even universities to get into the space business. I think it is a fact that a fair amount of startups around the world that have built space-bound infrastructure are actually coming out of university group and university team that develop specific ideas. And so this is, to me, a very important thing. Support the startup as well as support the university and the education in this case in Bahrain. Thank you for the opportunity, Sam.
Thank you so much, Guido. This is actually very exciting. We live in very exciting times, I must say. And I think you broke it down so well that we can really sense the broad applications here. And maybe before we move on to the next segment, I just wanted to ask Guido, where can someone go to learn more about the ground stations? Maybe where would someone start, like as a starting point to get involved with the ground stations?
We normally suggest our customers and people who contact us to go through the AWS website. There is a ground station page with the description of the process. There is AWS is known for being extremely transparent in the offer and in prices. So you can even find the pricing for the ground station service on our website. For those in the audience that are a bit more nerds, there is as well a blog, and I can actually share with Essam the links. I can actually try to share the links into the chat later on. There is a blog which actually explains what is the exact process that we use to set up an acquisition, and technical people can actually see how easy it is with this service to actually configure, set up, schedule, and achieve a successful acquisition using the AWS ground station service. And in any case, I've been in this business a long time. I know that there are always a lot of questions. If anyone of the audience had any specific question, either through the Q&A today or through a direct contact, you can reach out to me on LinkedIn. I'll be more than happy to answer any kind of question that might be a follow-up from this introduction.
Great. Thank you so much, Guido. We appreciate that. And I just want to mention that we do have a Q&A tab where the audience can ask questions, and we'll get to those questions towards the end of the session. And we'll share with you some of the links that Guido mentioned as well. Okay, we'll now give the floor to Dr. Bedoushi to tell us about how all these advancements and all these discussions really create opportunities for entrepreneurs and how we might be able to seize these opportunities. As way of introduction, Dr. Bedoushi Bhattacharya is a rocket scientist and entrepreneur with nearly 3 decades working in the sector. Not many of us can say that. She has experience working for NASA, and she has built the space sector scene in Singapore by finding the Entrepreneurs Hub in Southeast Asia, and the first technology incubator as well, which is the Bhattacharya Space Enterprises, which is a Singaporean startup dedicated to space-related education and training. So we're very lucky to have Dr. Bedoushi with us today, and we really can't wait to hear about these opportunities that people have today all over the world. And We'll take questions from the audience towards the end of the session, so we'll allow you sufficient time to go through your content. And we'll be also asking the audience a few questions as we go along, just to understand where we're at in terms of the different things that we're going to cover. So we'll be introducing a few polls throughout her discussion. So I leave it to you, Dr. Bidushi. Thank you.
Thanks. Thank you, everybody. I'd like to thank my fellow panelists, and I'd like to thank Tamkeen, the Global Entrepreneurship Network, and the government of Bahrain. So my goal here is to get you excited and enthusiastic about space. What I hope to do is to get you so interested that after this presentation, you go back, you start talking to family and friends, and think more about what your role in the future will be in the space sector. We are now in an exciting realm, as you've seen from the examples from my previous the speakers, that space technology is part of your world every day. You rely on it very heavily, and the sector is only going to grow even more. So let me just get into my presentation, and what you'll find is I'll give some examples of how I personally have been a part of this whole sector in the examples given by Rasha Al-Ahmad and Guido Barglielli, to see what I've done, and then to see what you guys can do to add to this sector. So let me share my screen. All right, you should now be seeing my presentation here. So one of the things that had been mentioned was a poll. If we could please get the first poll question posed, there will be a series of these throughout the event, just to keep you awake, and also so that I can get a better sense of where you are. So you should have the poll in front of you now. The question is, have you ever dreamt of being an astronaut? And your options are yes, I want to see planet Earth from afar, or no, I prefer to take advantage of the gravity here on Earth. I will make my selection and submit. And I think the rest of you can just take another minute to provide your submissions. And whenever, maybe in about 10 seconds, if we can have the results posted, that would be great. This is always a really fun question. So while we're getting the results, one thing I want to say is I first started asking this question in Singapore, which was mentioned at the beginning in terms of my introduction. And what really struck me was people in their 40s and their 50s talking about how they had always had aspirations to go into space, yet they had never actually had the opportunity to do that because there was no ecosystem in place in terms of education and jobs. So what I'm hoping to do here is to turn that around so that the people who are participating here in the next few years can actually come on board in the space sector. And being an astronaut is really a kind of fun way to think about going into space, because I'll tell you, I myself wanted to be an astronaut when I was a kid. And I've been fortunate enough to work in the space sector for my entire career. Are we able to get up the results of that poll? If not, if you could just type into the message, the chat room here what the results are, we can go over that. That's always a lot of fun. So the options were yes, want to be an astronaut or have wanted to, and no, I don't want to. So about almost 70% of you said yes. And that means the majority of people here have thought about being astronauts in the past, and that's pretty cool. Look, okay, great, the poll is showing up here. So most of us do have a vision of seeing planet Earth from afar. And the cool thing here is we can do that through satellites and through imagery of the Earth itself, which not only has the impact of inspiring us, it also has impacts on us on a very direct way in our lives. So let me go through the presentation now to give you a better sense of what I'm referring to. So what are my goals for this particular lecture, for this workshop? I would like to help you learn about the rapidly growing commercial space sector, which we call new space. And I'd like to have you learn about the unique vantage point and benefits of being in outer space. We've heard some information on that already. And I also want to talk to you about current astropreneurship enterprises in the region, and hope that if I do my job properly today, you will understand that there are technical and non-technical opportunities in the commercial space sector known as new space. And you will understand that rocket science is not mysterious and inaccessible. And you'll understand why new space needs you. So may we have poll number 2 at this point, please? So this question is important because I really like to get a sense of where people stand in terms of the space sector, just knowing what your knowledge level is. So poll question 2, how familiar are you with the space sector? There are a number of different options here. I like to use some fun terms for this. We can talk about being astro-curious, astro-knowledgeable, an astro-nerd, and an astronaut. So in fact, I do have some friends who are astronauts, and I don't think any of them are on this call, I believe. So then the answers will be between the first 3. I'm going to make my selection and give you guys just a minute to make yours. Great, may we have the results, please? Don't forget to hit submit so that your answer gets recorded. All right, 36% of us are curious. We have some people that have basic knowledge and want to learn more. And astronerds have worked in the space sector. We have a few of those. And then we have an astronaut, somebody who's been there and done that. I'm quite curious to know if you want to share in the chat who you are. It would be kind of fun to see who that person is and perhaps have them share their experiences as well. All right, I'm going to close this poll and then go on to the next slide. So let me tell you very quickly about our organization. We are Astro Hub. What we do is specialize in the democratization of space technology and services. And this means providing broader access, right? I mean, to date, I have been very fortunate and worked for NASA, but there are only a few thousand people in the US out of a population of 300 million who directly work for NASA itself. It's not a lot of people, it's a very small group, and in countries around the world, the government space agencies employ a very small number of people. But now things are changing, and what we want to do is allow people to come on board to work with us on the commercial side, which I think is very quickly growing to be larger than the government side itself. So we are based in Singapore and the USA, and we've been around since 2016, and our team has a combined experience of 45 years in small satellite development, spacecraft operations, and in astrophysics. And why we're doing this is we recognize that the sector is now moving into a realm where we need diverse skills. When I started working for NASA, my first job out of university, it was a very specific proof of technology kind of a project. And that was actually a realm in which we just wanted to prove that things would fly and work. But we're now into a realm where we need people who do a lot more than that. So my background is I have a PhD in space physics from UCLA, University of California, Los Angeles, and more than 30 years in the commercial space sector. And I worked on spacecraft calibration, mission planning, and I'm a speaker and do a lot with the media. Now, one of the things you heard about with AWS is how there are now APIs that help you figure out how long you have in terms of a window to get data from your satellite. And you can just do this on your computer. I don't know, maybe you can do it on your phone. I used to do that by hand. There was a team of about 30 of us for the Hubble Space Telescope, where we would sit and literally calculate to the nearest hundredth of a second how much time was available. And then we would type out commands in code and have them prepared to be sent up to the spacecraft. And you didn't want to leave any time to spare because it was $500 a minute. But I spent a lot of time writing these mission operations calibration schedules. And these days, it's just fantastic to me that you can get one of these sort of interactions done with your spacecraft just using an API rather than hiring a team of, lots of people to get it done. So I'm a CEO and founder of AstroHub, and I'm also on the Global Entrepreneurship Network Space Advisory Board. So I mentioned the Hubble. So here's a picture of me. You can see me, I will point way back here, one of the few women of color in this picture. This is when I worked on the Hubble Space Telescope about 6 weeks before the Hubble Space Telescope was launched into outer space. This was a team of 400 of us who worked on instrument calibration and on the science side, working with astronomers who are our customers to help them figure out how to use the data from the spacecraft. And you can see here, this was a guy, Riccardo Giacconi, who ended up winning the Nobel Prize a few years after he was director of our institute. So what I'm doing right now is talking to you about big space, which involves projects with billions of dollars. There's NASA, of course, and then many other government space agencies. The Hubble Space Telescope itself ended up being about $4 billion. And then the Galileo spacecraft, which is my favorite spacecraft of all time. It's the NASA spacecraft that went to Jupiter, cost in the end about $2 billion. And the reason it's my favorite is that's the one I use data from to do my doctoral dissertation. So very quickly, just to give you a quick sense of what we do at AstroHub is, I showed you this already, didn't I? Anyway, so we build a global ecosystem by doing workshops. You can see here somebody, this is at the Art Science Museum in Singapore, and we do these hands-on workshops, and we have taught at International Space University, and we run the NASA Space Apps Challenge every year. And this is a workshop that we did in Australia where we used what's known as a handheld version of a CUBE satellite. And that is actually something that I have right here. This is a desktop model of the satellite. We were talking about building nano satellite launch capacity. We have a desktop model that we use with users to help them figure out just the basics of space. You don't need to have an engineering degree necessarily to be part of the sector, but you do need some level of information and just some general knowledge. And I think once you provide that to people, they can on their own initiative go and learn more, and that barrier to entry to the sector goes away. So let's talk about you and why I believe you should be interested in outer space. As discussed earlier, you are already dependent on outer space, and the unique vantage point of space allows us to observe large segments of the Earth for purposes of agriculture or oil cleanup or maritime. There are a number of use cases already, and you may not even realize that the information that you're getting to conduct your daily life results is dependent on outer space. We're at a unique time in history right now. Every citizen on planet Earth has been affected by this pandemic. It is the first time in humanity's history that all of us have had some difficulties related to this a common difficulty, the COVID-19 virus. And we have issues like people waiting in line for foods. There's been global food insecurity all around the world. But this is also, I think, an opportunity. One of the things that Essam mentioned at the beginning was because we can now be on Zoom online, there's much greater global access. I mean, I know I give talks right now all over the world, places that I normally would not have flown to. It would have taken 2 or 3 days to get there, give the presentation and leave. I can give 2 or 3 talks a day now to people in Kenya or Bahrain or Japan. And it's very doable. The level of connection in some sense that we have is much greater. And I think for me personally, this is a really important time to develop diversity and global talent. As you saw in that picture, I was one of the few women in the picture. Most of the people there were white men, but I think we all have capacity culturally, intellectually that we need to bring in. And if you know about organizational management, the more diverse a team is, the fresher its ideas are and the more effective it is. And I really want to build the space sector to sort of become a diverse, all-encompassing field where human capital, the most valuable resource we have, is made a priority. So space opportunities equal jobs. This is really an important thing I want you to think about. It's no longer one of these distant, oh, some people do this, I'll go watch a rocket launch, it's pretty cool kind of thing. This is one of those sectors where we actually need you to come in. And there are a number of examples of applications of space that I'll give you throughout the presentation here. And let me just start out by talking about microgravity. When you're in outer space, let's just say you're in a satellite that's going around the Earth, you're going to be outside the pull of Earth's gravity, right? So you will see, often you'll see astronauts floating around, the hair is floating up in the air, and it's a lot of fun to watch them, but there are real medical effects due to what they do. And there's some really interesting industries that need to be developed in outer space. We talk about going to Mars. The UAE launched its Mars mission with the HOPE probe to Mars. It will land in just a few months. And so when you make these long journeys, what we do right now is we just send the spacecraft along with all the fuel it needs, with everything that you'll need for the duration. But when we start sending humans to outer space, to the moon or to Mars, it's going to be a different game altogether, right? You want to keep people safe. If a robotic spacecraft fails to work, we're all disappointed. There's some loss of money and people don't get the data that they wanted. That's disappointing. But when you have humans in space, it's a whole nother situation. You want to maximize safety. One of the things you want to do is give them the ability to build spare parts. So let's just say they're going from here to Mars, it's a 7-month journey, and there's some component that breaks. You can't take every component of a spacecraft and provide it to people. What you can do instead is 3D print what's needed from a basic element. And to date, this has actually been done on the International Space Station. The International Space Station is basically a satellite or housing for astronauts. It orbits the Earth every 90 minutes. It's been up there for 20 odd years. And there are 7 people at a time who are on this particular spacecraft, and they conduct research all the time. So there's a company called Made in Space that has been doing 3D printing, additive manufacturing in space. You can see here this little end of a rocket they've done. This is plastic, this is polymer material that they've been using to date. And that's well and good, it's a proof of concept. But what I'm particularly interested in the context of Bahrain, is the fact that Bahrain produces a lot of the world's aluminum, right? And aluminum is a fundamental component in many spacecraft systems. So nobody has tried yet to 3D print with aluminum in outer space. And what you want to do when you 3D print metals is actually use a laser to apply heat and then melt the material and then to layer it on in a special 3D printer. Now, space is a game changer. We've done this on Earth. We don't know how it would work in space. With the plastics, for example, plastics behaved differently in space than they do here on Earth. But making use of the aluminum that is already available plentifully through Bahrain, I think it might be really interesting for somebody to develop a 3D printing technology using aluminum in outer space. And that would be really valuable too, because when you are going from here to Mars, for example, you want to have different material options as well. Plastic may not be an appropriate material for a replacement of a component that fails for you. So the bottom line here, as I say in the bottom here in big letters, jobs, jobs, jobs. There will be many jobs in the next decade and beyond. So what I'm going to do is give you some examples at this point to help you think about where some of those opportunities might lie for you. So technology and pharmaceuticals, this I think is a fantastic area. I'm really interested in this, particularly because we talk about vaccine production right now for COVID. When you're in outer space, proteins crystallize differently because there is no gravity, right? So you can see right here, I've got this sort of jumbled up mess of crystals produced here on Earth. And when you see, what you see in space is a much larger and more organized crystals that form. And why does this matter? When you build a drug, often what scientists will do is model the drug on the computer. But you can't build it here on Earth because some of these molecules are so big and so complex that it's difficult to go ahead and put them together here. So you could, in fact, build these in outer space and then bring the base material down here to Earth to continue manufacturing. You can also do testing in outer space. There is a bone loss drug called Prolia. If you have an elderly grandmother, for example, a lot of women do end up taking this later in their life. It delays the loss of bones. And since astronauts in outer space have no gravity, they also have weak bones. So you can test these drugs in space much more quickly than you could down here on Earth. And you can look at bacteria growth. For some reason, bacteria grows very differently, and some kinds of bacteria grow very quickly in space. And this could help us to understand when it comes to producing pharmaceuticals as well. And if you're sending astronauts up there, they're in a closed environment, we need to understand why it is that bacteria grows the way it does. And our company has students sending experiments to the International Space Station. We're sending up our 8th experiment in a couple months. And one of the things the kids did was they sent up a tooth. One of the students had a younger brother who had lost 2 teeth at once. It was kind of fun. One tooth stayed on Earth, the other tooth went to space, and they monitored bacteria growth on both of the teeth. So space is no longer for the elite, like we're saying. These were students ages 14 to 18 who sent this experiment up, and they were able to conduct a research project in this way. So since I just did mention a post-COVID planet, one of the things that I really find interesting is we now have access to material here on Earth that was designed for spacecraft. I'm sure a number of you have seen these space bank blankets made out of mylar. So here is the Herschel Space Telescope. This is another one of these telescopes I worked on, and this yellow material is a mylar blanket. And this was initially developed for thermal management of spacecraft. And now you can just go on to Amazon, and this was $1.69 when I last looked it up. You can buy a bunch of these. And what you can do with these is use them in terms of camping. And if you've ever watched people running races afterwards, they all wear these gold and silver blankets. Those are mylar, and they're like just a couple bucks each. And this is a globally available product. The reason this is interesting is a bunch of space nerds build this for a spacecraft, right? Somebody figured out here on Earth, a social worker or a medical person, somebody, hey, here's a great space product that can be applied to our life every day. And now this material is manufactured and these are available. I mean, I can go and pick up, a dozen of these. If I order them on Amazon today, they would arrive at my door tomorrow. And it's actually space tech that I'm using. And if you haven't had a chance to order these and you get to, they're really pretty fun, because if you pull them out and you put your hand just inside of them, you'll feel the heat radiating instantaneously. It's amazing material, and it's helped people on Earth countlessly. I mean, refugees use them. They're in first aid kits as well. So what's made all of this possible? Let's look at the evolution of technology. This computer that you see on the left here is one of the computers that I actually used when I was on the Hubble. It's an Apple computer from way back when. And in today's dollars, it would have cost about 55,000 US dollars. So what do we have today? I have in front of me right now a mobile phone. As many of you have your phones in your hand right now. My phone is 150 times faster, has 200 times more memory, and is 100 times lighter than the computer that you see on the left side of the screen. So rather than 55,000 bucks, you can spend 800. If you want to get an iPhone, or if you prefer a different model, you can actually spend a little bit less. And you have access to this amazing technology today. So okay, so technology is miniaturized. What does that mean for outer space? Because the technology is miniaturized, you can take a lot of components that used to take the size of a room, computers, for example, and processors, and fit them into a satellite that fits in the palm of your hand. You can see here the satellite that I showed you a little bit earlier in our presentation. This is a Cube satellite. It's a desktop model. This is not one that we fly. It's used for learning purposes. And in fact, it is something that people can use and just take apart and put together and get a sense of what's going on in space. So we've had miniaturized technology, and what has that actually led to? We now have launches from around the world on a regular basis. And just recently, a few hours ago, in fact, we had an Emirati satellite that was launched into outer space. And this is such a common occurrence now that you don't even notice. This is something, when it used to be in the old days when there was a rocket launch, those of us who were space nerds, we would tell each other about it. And I remember in university, we would go and watch the launches on the big TV in the student union. But now it's so commonplace that you may not even think about it. You think, oh yeah, there's another launch, that's great. So let me give you some historical perspective on disruptive innovation. 150 years ago, everybody used horses and carriages. They were the primary mode of human transportation for millennia, right? We had horses, we had farms, we had breeding programs, we had entire sectors, entire industries built around supporting the use of horses. And then what happened? All of a sudden, we came up with the Model T car. When this car first came out, it was not very popular. It was loud. It was very unreliable, and it scared horses. Now, these cars would actually backfire. The engines were not well constructed, and horses would get terrified from the noise, and they would start running away with their passengers, which is, somewhat funny, but I know it was actually kind of risky for people. So we've gone from the gasoline-driven car to the electric car. And from the gasoline-driven electric car, we now have travel to outer space on a regular basis. So this is an evolution of transportation. Nobody at this point would think about using a horse and carriage to get yourself where you need to go. It would be incredibly slow. We now have hotels and fueling stations, every, hundreds of kilometers apart. Whereas in the old days, a horse could travel like 30 or 40 kilometers per day. So you would have hotels along a certain route, very frequently, so that people and the horses could be served. All of that is gone. But we can't imagine going back to it. And so now we're moving to a realm where spacecraft and access to space is going to be available on a regular basis. And as I said to you earlier, the access to space is democratized, and we have students launching experiments here to the International Space Station on a regular basis through our company. So let me go next into talking about space-based solutions for planet Earth. There are a number of areas where we use space technology. There are lots and lots of examples here. You've heard some of these from the previous speakers, but I'm just going to give you a sense of 4 of these very quickly. And what I'm going to do is tell you a little bit about what they are about, and then think about the non-technical ways in which people can support this particular product or use case. So we talk about space-based internet, food security, climate challenges, and urban development. Let me start out by talking about space-based internet. SpaceX has launched a satellite, SpaceX has launched, I want you guys to all try and say this, a set of satellites called the Starlink constellation to enable us to provide internet all over the world to remote locations. If you live in an urban area, internet is not an issue for you. But there are many people now who are at home because of the pandemic who don't have access to internet. And one of the things that they did was they provided internet access to a remote Native American tribe, an American Indian tribe in Washington state. And the students there had their access to the internet improved by a factor of 1,000. The data rates went up by a factor of 1,000 thanks to this constellation. The eventual goal is to provide global access with 30,000 licenses, 30,000 satellites covering the Earth. So this image represents, each of these dots in this mesh represents a satellite that will be up there providing internet, whether you're in rural Africa or in rural parts of the US, rural Australia, any place that you are, you will be able to get internet at usable speeds. Let's talk about food security. Now, this is an interesting area where we heard before about how you can measure, you can get information on crops on Earth to measure their health, to measure the state of maturity. And they did a project in South Africa where they were looking at crop readiness and health, and they wanted to understand maturity of the crop so that when a farmer calls a truck to take his crops to market, the farmer doesn't have to reserve the truck for a month, not knowing exactly when his crops will ripen. In the old days, people used historical models, like typically you will say corn will ripen at a certain time. But with climate change, all bets are off. There's really no consistency to when crops will ripen. You have to actually actively monitor them, and doing this from space is very effective. And this helps you get the supply chain going and getting your products to market. It turns out 40% of crops actually spoil before they reach market, and so space can offer a solution. So that sounds good, right? But here's the question. Here's where we need people with cultural competency, people who work in the social sciences to come in and help us. They took this data to some farmers, subsistence farmers in South Africa. These were people that ran their own local family farms, and they were not very financially very well resourced. And they were told, look, you have on your phone this opportunity to get information on your crops so that you can get this out to market quickly. And they had to be convinced that they should spend a small amount of money for a technology they don't really understand, and that they would get benefits from that down the road. That's not a technical problem. That is a social and an economic problem. And that's something that I, as a space nerd, would not be qualified to immediately address, but I would want to work with a team of people who could go in and culturally and appropriately explain the economic benefits to these South African farmers so they can come on board and use the technology. And we need to address those kinds of challenges too. Similarly, let's look at climate change. When I'm in Singapore, if you've ever been there, every year there is a huge cloud of smoke that hovers over the country because in Indonesia, farmers are clear cutting by burning their farms down to put new palm plantations in place. So what that does is creates a huge public health menace for the people who live not only in Indonesia, but around the local region as well. So if we can use satellites with infrared cameras, as was mentioned, to detect the source of these fires and put them out immediately, that is of huge value. There's a big difference between finding a fire and putting it out within a few hours and getting a satellite image that's days and days old and then trying to put out the fire. You're going to have a very different challenge if you wait very many days. So in Indonesia, what you want to do there is give the technology to farmers, but you have to think about economic options because they are clear cutting for financial reasons because they need to be able to feed their families. So what they're doing is providing the environment at risk, but somebody needs to go in there and work with them to help them understand why using this data is important for them. Similarly, I mentioned earthquake victims here. In the Nepal earthquakes a few years ago, they were actually able to use satellite data to identify villages that had been completely cut off and then send in airplanes with supplies, with emergency supplies for those villagers until the roads could be cleared to actually rescue those people. And finally, in terms of our solutions here, let me talk to you about construction. There was a tribe in New Zealand of indigenous people who owned some land, and they were concerned about encroachment. They were concerned that there was a development interest that was building on top of their own native land that they had been allocated by treaty, a long time ago. And the way they decided to address this was they went and got satellite imagery to show that this construction was taking place. So they could look and see where their land was. They could look at images from, a few months ago and look at images of the same location now and very readily prove that the development had happened and that it was not supposed to happen in that particular location. This is a much easier way to go than actually trying to travel to a particular location and take photographs on the ground, because with the images from space, you get the location very precisely. So here again, this is a social benefit that's coming to us from outer space. And we can also use these kinds of images to address environmental threats. So what if there is some, there's some bleeding of construction water into the local water source or pollutants? You can use images from space to get at this as well. Right, so let me go on to the next slide. And what I'm going to do now is shift gears and talk about, space missions and what's happening and what will happen in just the next few years. So in 2019, last year, on the commercial side, we had a demonstration of the SpaceX crew capsule. Humanity has been using the Russian rockets to get people to space, and we were looking at using commercial options. So last year, SpaceX successfully demonstrated this. There was a solar sail project that was done, light sail that worked. They talked about developing Starhopper and Starship projects, and there were the constellation I just told you about started launching last year. And then a company called Virgin Galactic, which will do space tourism, flew a test passenger, and the company grew and went public, which means they trade on the stock market. First company to do that. On the government side, China landed on the far side of the moon. There was an all-woman spacewalk. A female astronaut began a year-long mission in outer space. We've studied the effects of space on astronauts, and to date it's been men mostly, but now we're also studying women to get a sense of how all of humanity is affected. And the Indian moon mission Chandrayaan crashed on the surface of the moon. India destroyed its own satellite in space, and the Israeli Bereshit lander also crashed on the moon. And NASA marked the 50th anniversary of the Apollo 11 mission and looked at heading to the moon in 2024. And this year, there's a lot that's happened already. The SpaceX Dragon flew people commercially to the International Space Station in May of this year. Between June and November of this year, there is a rocket company called Rocket Labs, offices in New Zealand and also in the US. And they've been launching rockets every 6 to 8 weeks to take satellites up to space for commercial and university and government contractors from all over the world. And this is happening so frequently that you may not even be paying much attention here, but it's just the sector is growing. This is happening on a regular basis. And we mentioned Starlink earlier. They have put up 120 satellites to date, and they're putting up more and more as time goes along. And on the government side, this was a big year for Mars. Every 2 years, the alignment between Mars and Earth is suitable for launches. So if you think about it, you have the sun, and then you have planets moving around the sun. And Earth is circling the sun and Mars is circling the sun. So every couple of years, they sort of, as they're spinning, catch up. So the distance between them minimizes, and that's really the best time to launch, because then it becomes something like a 7-month journey, which is, sounds like a long time, but when it comes to the distances in outer space, that's actually pretty good. So in July of this year, you had this launch window where the UAE launched its HOPE spacecraft, the first mission to Mars built within the UAE, the first country in the Mideast to actually send a spacecraft to another planet. It will be landing in just a few months. NASA similarly sent up the Mars 2020 mission, which will try to generate oxygen on Mars, has huge implications. And then China, just yesterday, China landed its Chang'e spacecraft on the moon. It's a lunar sample return mission. So what they're doing is they've landed on the moon successfully. This was like less than 24 hours ago. And they are now digging around, grabbing samples, and those moon rocks will be brought back to Earth. And what's interesting here is they're looking at a different part of the moon from the previous samples that were obtained. Those were obtained back in the 1970s, before many of you were born, by the Americans and also by the old Soviet Union, now the Russians. And so we're getting more and more information from space. And just parenthetically here, the Japanese have a spacecraft called Hayabusa that has actually taken samples from an asteroid. Now, asteroids are the small rocks that orbit the sun as well, between the orbits of Mars and Jupiter. And they're very interesting because they are kind of a planet that never came together. So it's very pristine material from the early solar system. And the Japanese will be bringing that material back here to Earth as well. So that's supposed to happen in December. So December 2020 could be a really interesting year in bringing material back to us from outer space for scientific research and for study. So since we're talking about countries all around the world, let me give you a quick sense here of startups. So there's a database I have access to called newspacehub.co, and they list the startups that are in the space sector around the world. I looked this up yesterday. As of yesterday, there are 1,928 startups in the space sector around the world. This is a self-reported database, and those of us who are in the know go in and put information in regarding companies as they come up. So this, I won't say this is complete. A lot of startups, they start out working, in a physics lab in a university or something, and they don't report themselves as a company as such. But 1,928 startups around the world. And here's what I want you to look at. The majority are in Europe. There are a few in the Middle East, and then in South Asia, Australia, and then of course in North America. And people are working in everything from additive manufacturing, 3D printing, which I already mentioned to you, agriculture. You can go through this list. There are many, many areas. Ground stations, there are startups working in this in addition to what AWS is doing. Medicine, propulsion, weather, tourism, and so on. Lots of areas where people are starting to put their intelligence and their interests to work here. Let me zoom in on this map for you just to contextualize this to today's audience. We have here a number of companies in the Middle East. We have 7 in the UAE, 4 in Saudi Arabia, 2 in Kuwait, 1 in Qatar. And so that ends up being a total of 14 companies right now in the Middle East doing space-related work. Can we put up poll number 3 at this point? Or actually, yeah, let's put up poll number 3, and then we'll do poll number 4 as well. So poll number 3, how much does it cost in US dollars to build and launch a handheld CubeSat satellite? So this includes the components, the testing, and the rocket launch. It's not going to include your labor. So at a university where students work for free, how much would you say it will cost to build and launch one of these CubeSats in US dollars? 300,000, that's about the price of a Ferrari. 1.5 million, 5 Ferraris, I guess. And then 3 million as well. So give me a sense of how much you think it costs. I'm going to submit my answer. And just as a hint, I'll tell you, the computers that used to cost $55,000 that I showed earlier, a computer that's much more powerful than that actually costs about 800 bucks right now on your handheld phone. Could we get the results? All right, so it looks like most of you guys are spot on. Yes, 80% of you gave the answer, which is correct. For 300,000 US dollars, you can actually go in and build and launch your own spacecraft. $300,000, think about that. That's a satellite that I was showing you, the one that I held in my hands. 1.5 million, yeah, that's what it used to cost. 3 million, certainly that is what it used to cost maybe a few years ago, but we've now got a game changer. I will close this one, and may I ask at this point to have the previous, the poll number 4 shown, and we'll go ahead and answer that one as well. And this helps to contextualize the map that you have on your screen. Where are you currently based? I'll tell you for myself, since the pandemic started, I have been here in California, haven't gone anywhere. I was actually in Singapore and left a conference early because they were starting to have some hot spots where people were getting COVID there. So people who were attending all left a day early. But I know many of us are not traveling at the moment. But as I said, my offices are located in Singapore and in the US, and I used to have a lot of miles flying back and forth, but I'm in North America. So I'll go ahead and put that down here. And I guess if you've hit on that, then we can go ahead, maybe get the results of the 4th poll, please. All right, so the majority of people are from the Middle East, 3/4 of us, and that might be expected. We have some from Africa and Asia, nobody from Australia. With the time zone change, I suppose that is not too much of a surprise. And then not many people, nobody from South America and North America. I'm gonna guess that that might be just me and maybe one other person, depending on how many people we have on the call right now. So yeah, so most of you are in the Middle East, and that's why this slide that I just showed you is important. I'm going to close my window. So you can see at this point, there's a total of 14 companies that we know of that are working in the space sector as startups in your region. And you can see there are many more in Europe, and in South Asia, there are a number of them as well. So what this tells me is there's a lot of room to grow. There's a lot of opportunity for you to come in and build your own ideas and to build your own entrepreneurship, your own business. Let me give you one example of a company. So I want to look at this company called CubeSat Arabia. And these guys are looking at designing and developing CubeSats for research and for education. And again, they're talking about putting space technology into your hand. And this is the key, is giving people access to space. So their product line at the moment includes mission planning, helping you integrate and launch a CubeSat. They work on designing CubeSats and also on training, which is the same thing we do, because again, we're talking about awareness and we're talking about building the workforce. So after we've talked about all the companies there are around the world, and I noted to you on the map, there are so many companies that are working in so many sectors. I'm going to break that down for you a little bit here to just talk about what sectors are currently active. So there, I've just put up 12 of these. Now you can break this up in a number of different ways, but we're talking about Earth observation, satellite manufacturing, and you can look through all these yourself. But in space manufacturing, we talked about 3D printing, using material, using aluminum from Bahrain, for example. Talk about big data and storage. We talk about ground systems, and that's where AWS comes in. So why don't we put up poll number 5? And I just want to get a sense, I'm kind of curious to think about what kinds of problems everybody might want to solve using space technology and considering all these sectors as they are. It's a very broad question, but I'm just curious to see where you guys are, what you're thinking about right now. So in which space-related application would you be most interested in working? Agriculture, telecommunications, disaster relief, or urban development? Now this relates to the images that I showed earlier, you know, where the circles were moving back and forth, where we talked about images of the Earth taken or satellites that were helping to address these particular problems. And I myself am choosing agriculture because being here in California, one of the things that I have been affected by is supply chains. We are in this crazy era now where you can go to the grocery store and sometimes certain products will just not be available. I mean, the shelf will be completely empty. One example is flour. I went to buy flour. We just had US Thanksgiving here, and they were basically out. And that's a staple, right? And so getting the products from the farms to the supermarket has become quite a challenge. And so, you know, in a very real way, I'm feeling this shortage. So I'm going to hit submit here. And it would be great if you guys could hit submit. And then if we might get the results, I think that would be quite interesting to see what people are thinking about. Agriculture. So most of us are thinking about, half of us are thinking about farming and agriculture and the ways that space technology can help with that. Telecommunications, also important in disaster relief. And then a quarter of us are looking at urban development. Now that's interesting. I typically don't have that many people looking at urban development, but I suspect what's going on here is people live in certain regions and they face certain issues, maybe with overdevelopment and construction. So a number of you are interested in all of this. Very cool. So let me close this and then talk about the number of investments that we have to date in the space sector, and then talk about some of the skills that will be required to address that particular area of interest that you might have noted in the poll that we just closed out. So urgent economic demands are going to lead to more space investments, and we've had $5.4 billion of investments to date. And this is from the company's Space Capital that was mentioned earlier. And startups have been growing at an exponential rate. And this, if in case you can't see this very clearly, on this axis here is time. And on this axis here, we have the amount of money that's been invested to date in the space sector. And you can see we've gone from very little, there've been some milestones, and right now we're talking about $110 billion invested cumulatively to date. So we talk about a $3 trillion space economy. There have been some studies done by a number of financial companies and by a number of industry experts who have projected what we need and where the things will go given the current rate of demand. $3 trillion global space economy by 2040. That is in 20 years, 19 years almost, right? And why is the sector growing so quickly? Again, as I had said before, when I started working on the Hubble Space Telescope, we referred to the space sector as a proof of technology sector. You would build it, you would fly it, you would see if it was working, and then you'd go and build something else. We're beyond that to where we now have standardized components for spacecraft, and we're providing regular customer products and services. And so we're moving into what's really an ecosystem, a business. So here's my big question for you. Where is the workforce going to come from that's going to help build this economy out? You can't just have people coming in who have degrees in space physics like I do, or engineering. That's a small segment of us. And yeah, we can help to build and operate these spacecraft, but there's so much more to it than that, right? There's so much more to it than that. So what we really need to do is focus on training and educating others who have other areas of interest and other areas of specialization. So let me just talk to you about business and marketing. If you have a background in business or marketing, or media communications, or a legal background, or finance, here's some things that you could possibly do to contribute to the growing new space ecosystem. In business and marketing, you can look at sector growth and customer acquisition. And you don't have to have an engineering degree for this. As a matter of fact, I would say that I, without a business degree, might not want to engage in this. You, if you have a business degree, would be much more qualified. What you need is just a little bit of background on space. You know, just like if somebody is working to sell medical equipment, they don't need to be a physician. They just have to generally have an understanding of the applications of the product, right? So here you just have to have an understanding of space itself. If you're in media and communications, I think this is a huge area. We have a member of our team who's very good at this. She's a media comm person. We need to get consumer buy-in and tap natural inspiration. So space is an easy sell, right? I'm sure many of you signed up for this workshop thinking, oh, space, that's kind of cool. I've never spoken to anybody who has looked at me, you know, and said, oh, you're working in space, that's kind of boring, isn't it? Everybody's inspired, everybody's excited. We just have to be able to tap that and get people to think of space as part of their everyday lives. And that's where media communications people come in. Legal, there are property rights. And as was mentioned earlier, there are United Nations cooperative treaties. We have to think about what it means to go into outer space, who owns outer space, What happens if somebody goes and starts digging around on the moon and bringing back all that material and a country gets very wealthy from that? What does that mean for other countries? How do you establish ownership? These are all questions that have to be answered. Who owns the satellites once they're in space? What if 2 satellites crash into each other? And that's happened in the past. Who's liable for that? Who goes and cleans that up? That's an area that actually is a big concern and an area of development right now is space cleanup. So, that's an important area, legal. And then finance, of course, this is what it comes down to for startups on a regular basis. Funding for startups. Somebody has to figure out an effective way to fund startups. There's a perception that space is super, super expensive. We're talking about, millions of tens of millions of dollars of price tags. And it really depends on what you're doing. If you're building small components or if you're working on the data analytics side, it isn't that much anymore. Remember, we talked about the handheld satellite, the nanosat, the CubeSat, and that costs about $300,000 right now. So, for any of us who want to pull that money out of our pocket, it sounds like a lot. But in terms of investors, convincing them to make what they would consider relatively small investments, that's an important thing. And that's something a finance team can help to work out in terms of building the economy. So what about some other areas? Let's just say you have an interest in or a background in medicine or biological sciences, social services, engineering and science, not space related, or in the space sector, professional space workers. How can you participate? And these are just some ideas I'm throwing out there to you. I am sure that many of you will go home and think about this, talk to your family and friends, and come up with even more ideas for, you guys are younger, you're what I like to call non-linear thinkers. I am, at the age now where my thinking is more standardized, but I'm hoping that you, with your view, you guys are all very used to computers. You grew up in a very different digital world than I did. I'm sure you'll come up with a lot of ideas that are just not being presented here. But let me just start you off by talking about some of the ideas here. So you can talk about pharmaceuticals in space, which I mentioned earlier, space tourism. So this is an interesting area. Everyone talks about space tourism, but I have not heard of anybody developing a medical protocol for space tourists. We talk about sending people up in the next 10 years to outer space, and there is talk of making space tourism, the same price as a first-class airline ticket in an international flight. And so you would go up into space, orbit around for 4 or 5 hours, and then you'd come back down. But everybody who's gone to space so far is a perfect human specimen. Astronauts are very fit, they're in great shape. What happens when you send a middle-aged person like me to outer space, for example? I told my husband I want to take him to outer space for our 50th wedding anniversary. We just had anniversary year number 29, so we have 21 years to get there, but I want to buy us tickets to get to outer space in 21 years. But at that point we will be older, and people take medication. What happens when you send somebody who is an actual citizen of Earth, with health conditions into space rather than a marathon runner, a perfectly fit astronaut? Somebody has to conduct these kinds of studies, and there's data out there already that somebody just needs to build upon. And I think this is a great opportunity. When you work in social services, that's the next example. You can apply space technology for the greater good. We talked about all those images that are helping farmers. We talked about those mylar blankets that help refugees. And I'm sure there are many other technologies that can be applied by people who are aware of social and economic services that can help humanity and the citizens of planet Earth. Engineering and science, technology transfer and new applications, those are important because I may think of using a tech in a certain way, but let's just say that you're working in biophysics and you have some technology that's used here on Earth to help people who maybe they can't walk or something. Can that be converted into a device that works with a spacesuit, as one example? There are a lot of transfer technology applications there that people can think of. And then of course, if you're in the space sector, you can just continue to push boundaries in terms of tech development. So I've offered you guys a lot of information here, a lot of material. And what I'll do at this point is just give you a sense of how you can actually get involved. We do offer workshops these days. They're just online. The next ones coming up are in January of 2021. You can go to astrohub.co/webinars and sign up. It'll be a 90-minute seminar, and we'll go into some of the stuff that we talked about today in a little bit more detail. And I'll work with my team member, Professor Sharan Asundi, who actually has launched a number of CubeSats himself. So he'll give a little bit more detail about CubeSat systems. So I think with that, I would like to just put this up and say, if you want more information, here's some websites and various locations you can go to learn a little bit more. And I would like at this point, if that's okay with everybody, to just open this up to questions. And I don't know how you want to run this. If you want to just tell each of us what questions to answer, but you know, I'm ready whenever you guys are. Thank you so much.
Thank you so much, Bidushi. That was extremely valuable information that you had shared with us. We'll allow the audience to ask any questions that they might have. They can type it up in the Q&A tab available below. So you can go ahead and do so right now if you have any questions. So Bidushi, are you able to see the questions that are posted?
You know what, I'm going to stop sharing my screen. I bet that will bring it up.
Okay, there's a couple of questions from the audience.
Okay, let me bring that up. Right, so I'm gonna go to my Zoom window. Sorry, give me 1 second here. I've got multiple monitors, which makes it a little bit more. All right, thank you, there we go. What are my views on SpaceX? Well, interestingly, I started looking into the commercial space sector when I was working for NASA, and several people on projects that I knew started leaving NASA to go work for some company called SpaceX. And I thought, I wonder what's going on there. So what they do is they have infinite piles of money, and they've done some really cool things in terms of tech development. And I think the most important thing that SpaceX has done is provided inspiration and tangibility to the public. So, you know, when Elon launched his red Tesla into outer space, that was pretty cool, right? It got people's attention. So he's done a good job bringing global attention to the sector. And he's also, you know, putting some ideas out there that have not been tried in the past. So his company is no longer a startup, obviously, they're quite huge, but they're doing things that are very important. Aside from monitoring biomass, what are other applications of space tech in conservation and ecosystem restoration? That's a very broad question. I can give you a couple examples. You can look at water usage, you can look at pollution, any of the stuff that you're interested in, you can just send me a message later, or just go ahead and start looking online. There's a good website called spacenews.com that provides an overview of what's going on. And you're asking the right question here. And at this point, the only way you can get these answers is by either Googling, as I suggested, or you can go and you can get an engineering degree in space systems where you figure this out. So that middle ground that you're at is probably where you are, and our workshops do come in that area. But yeah, there's a lot that you can do, and you're asking me what the applications are, but I'm sure that if you think about this, you yourself might be able to come up with some yourself.
What was the website you mentioned?
Space News, shall I put it into the text
yeah,
chat?
If you don't mind.
Yeah. Yes. Yeah, let me go ahead and put that in for everybody. And so there are a bunch of these websites, right?
Mm-hmm.
Spacenews.com, there you go. And how can you prepare kids of 5 years and younger to enter this sector? Kids are enthusiastic, kids are excited, and I think it's not too difficult to get them involved. The thing I find, and I have 2 children, they're now in their 20s, but when they were younger, the things that kids get excited about are outer space, and they just seem to love dinosaurs, right? So if you could talk to them and get them information, have them watch launches with you. I mean, I think, we were talking about SpaceX, their launches are just on their YouTube channel. And they're pretty darn cool. They're loud. They do a good job with the graphics, I think, even for younger children. And when you watch those boosters landing again, that's also pretty cool. So that, I think, is a great way to get kids involved. And I'll just tell you, the way I got interested in space is I was 10 years old, and we watched the US NASA send pictures back from the surface of Mars. Now, this was back when you had to watch the news on television at a specified time. There was no capability to record programs. So my parents let me and my sister sit in front of the television to have our dinner that night. And I was just blown away watching the images come back down to Earth from Mars, which was this place in the sky that I had read about. And that's when I really got hooked. So starting somebody out early, I think that is a great idea. When will humanity go, when will Mars be reality? You know, a lot of this depends on funding, and a lot of this depends on building our workforce. We talk about sending people to Mars, and you know, Elon Musk says 2030. People have a lot of numbers out there in the next 10 to 20 years. I think it will happen. But I see gaps in the development. One of the things I mentioned was space tourism and the need to medically understand who can go and who cannot, right? And in the longer term, you will need to send people more than just astronauts, but this is a problem that has to be addressed in accordance with what's being developed on the tech side. So what sorts of jobs related to space can an undergrad physics student get? I was an undergrad physics student. I actually did my undergraduate degree in physics and mechanical engineering. And at the time, I worked while I was in school on a data analysis project looking at a bunch of elliptical galaxies. Now, those are galaxies that are shaped like eggs, and did some modeling with them with a professor. And he recommended me for a job on this new project that was coming up called the Hubble Space Telescope, and said, would I be interested? And you know, that led us to today. With your interest, I would say go ahead and look at spacenews.com and keep going in terms of, you know, looking at what's going on out there. If you start to follow the sector, you will see areas of growth. And if you start to follow the sector, you will see areas where there may be gaps, and just get a sort of, I would say, holistic sense of what the sector is about, and you'll be able to find your spot in there. Now, remember, when you work in space, nobody's out there teaching you, how do you send somebody to Mars? You have to take the skills you have and have the ability to learn. Know that you're going to figure it out as you go along. Every job I've had, there's been no training in my formal education that allowed me to understand what to do in the job. You had to figure it out. But you know, your team that's working with you, everybody's going to be figuring this out. So if you consider the idea that you have transferable skills, if you have enthusiasm and you have interest, you can start looking around. And I would say you could also go ahead and provide, you know, do your own startup. Don't hold yourself back there. You know, think about what can be done in startups as well.
I'm curious about Rasha's, if you allow me, Dr. Badushi, for a minute too. Curious about Guido's and Rasha's background as well, in terms of academics and how that sort of led them to work in the industry.
Mine was actually a case of being in the right place at the right time. I have a completely different background as far as my education is concerned. So space was kind of an hobby and became my lifetime. I started mid-80s. So I do have, I'm one of the few that Badushi said has 30 years in space. Basically you can think about any possible education, because Dr. Badushi said quite right about medical condition, but as well, I'm pretty sure you want to have a counselor on board of a starship that goes to Mars, and just not to go down to the Star Trek narrative, but the living in a confined space for a longer period of time. We know it's hard to be confined these days, so do that for 9 months, 12 months to go to a distant planet. That will be extremely difficult. I just want to take the opportunity to answer the question regarding what we can do with satellite. Basically, anything that concerns conservation of the environment can actually be applied to a satellite mission. Biomasses are one of the many elements that a number of different companies are actually collecting information about. Just imagine that the easiest thing to do with a satellite is change detection. So you take a picture today, you take a picture in 6 hours, you take a picture in 24 hours, and then you use machine learning and artificial intelligence to detect all the different changes. You can see erosion on rivers, you can see landslide, you can see as well urban development. But at the same time, you can also use specific sensors. I was talking to a company in France, which the sole purpose of the satellite sensors is to detect methane. So to detect gas leaks from pipes, but as well from produced by biomasses, produced by farming. And they can actually provide images of the surface where this gas is actually highlighted, and measurements can be done on the density, on the quantity, on the timeline of the gas emission. So basically, you have an idea. I'm pretty certain that someone could create a sensor in a spacecraft that will actually be able to collect the information to realize that specific idea.
Okay, and so Issam, as for my education background, I come from an IT background, and my work background relates to planning, project management, and strategy. So this is where I fit within the NSSA.
Thank you. Did we answer all the questions?
May I actually ask, there was one more poll question that I did want to put up. Is it possible to put it up at this point? All right, so this question asks about, now that we've talked about the sector and you've understood the use cases from everybody, what fields of education provide the skills needed for space-related, for you to work on space-related products and services? So based on what you've heard today, would it be engineering, science, media, communications, law, economic, social sciences, biological sciences, media, business, marketing, or all of the above? And I think you know by now what I'm going to say the answer is. I'll click on mine. And if we could get the results up in just about 10 seconds, give everybody a chance to answer, that would be super. All right, so the majority of you do believe that 80% of you believe that skills in all of these areas are needed to build up the space sector. And I'm glad to see that. I think some of the other areas that are noted are critical, but what I will say is all of these areas are critical. So if you're in engineering or science, that's great. Biological sciences, medicine, that's great. But all of the others that are mentioned, I think are also very important. So depending on your background, I do hope that you will join us. So yes, all of the above. I'm gonna go ahead and close mine. And thank you for letting me interrupt with that last poll. Assam, I'll leave it back to you.
Thank you so much. So I think this brings us to the end of our session this evening or morning for Dr. Bidushi. It was extremely useful to be sharing these insights, with our audience. This is a completely uncharted territory, and like we mentioned earlier, Bahrain started its diversification program many decades ago. And I truly believe it's these kind of conversations and discussions that really help us to, further innovate and push the boundaries and continue to diversify our economy. And it's definitely not very far-fetched. At least that's something we learned today. So I hope you and the audience are left with inspiration and would pursue and explore this further. I know I would. The panelists have kindly shared some links and information with us that can help us in actually continuing this endeavor for us. So thank you for that. And lastly, I want to thank you all individually, Dr. Bidushi, Mr. Guido, and Rasha. Thank you so much for taking the time to be with us. This is the first time we ever conduct a virtual GEW. Due to the circumstances, but I think it also helped us in having experts such as yourself in one room, one window. So we're thankful for that. And we hope to continue on this and maybe delve into more specific conversations around this industry in the future. Thank you so much, and we hope to see you all very soon. Thank you.
Thank you very much.
Thank you.
Thank you.
Thank you.